Okay, this is section 2.2, looking at organizing quantitative data, and we're going to look at some of the most popular displays. So you can see all of our objectives there, but the big idea is we're going to be organizing discrete data into tables and creating what's called a histogram. And then we're also going to talk about a little bit more about discrete versus continuous. And so quite a few objectives, quite a few to get through in this lesson. But we'll make it through, and at the end I think you'll have a lot of good information. So the first part here, when we're trying to summarize quantitative data, we first have to determine whether the data points are discrete or if they're continuous. If they're discrete with relatively few different values of the variable, then these categories of data, and when we talk about categories of data, or call them classes, will be the observations, kind of same as in the qualitative data. Okay, if they're discrete but with many, many, many different values, so they're kind of all over the place, or if it's continuous, then we are going to put these things into classes and we'll create what we call intervals. And so I'll first present to you the techniques for organizing discrete quantitative data when there's relatively few values, and then we'll go into the bigger continuous and quantitative stuff. So in this first video, or not this first video, this first problem that we have here, we've got a manager for Wendy's of a fast food restaurant wants to know the typical number of customers who arrive at Wendy's for 40 randomly selected 15-minute intervals of time during lunch. So for example, during one 15-minute interval, 7 customers arrive. So that would be this first set. And we are going to construct a frequency and relative frequency distribution of this data. So remember that when we're talking about frequencies and relative frequencies, we're going to count up the number of times a certain event occurs, and then look at those proportions. So we're going to build this thing in StatCrunch. So I need to come over here to StatCrunch, and just a reminder how you get to StatCrunch. Okay, so it will be where did we go? It's probably right there. It is. So under your links, click on StatCrunch, and then you're going to launch it in a new window, and from there you will eventually. Oops. Oh, I did want to launch a new one because I wanted a blank slate. So StatCrunch website, and open in StatCrunch. So all of those clicks will finally get us here. Then I am going to enter in all of these data points, so 75262, 66752, and so on and so forth. So I'm going to pause the video and get all that stuff put in for us. Okay, so I've got all my data in here, and again, each of these represent how many customers came in a 15-minute window. And to get my frequency distribution and my relative frequency, I'm going to go to stat, table, and then frequency. I want variable 1, and then I'm going to highlight frequency and relative frequency. I just held the shift key to get both of those and compute. Okay, and here I have I've got my distribution. So one customer occurred once, 2 customers occurred 6 times, 3 customers 1 time, and so on and so forth. And then you can see their respective proportions. And so that breaks down all of our data, all of those single data points, and gives us something that's much more quick to see. So we go from all of the set of data to a summary in a frequency and relative frequency table. So now we're going to look at this idea called a histogram. Okay, and a histogram is constructed by drawing rectangles for each class of data, and the height of the rectangle, so the height represents either the frequency or the relative frequency of each class, and then the width of the rectangle is the same, and the rectangles will be touching each other in these histograms. So as you can see down here, the number 1 occurred once, so it has a height of 1. And then the number 2 occurred 6 times, so it gets a height of 6. Then the number 3 occurred once, the number 4 occurred 4 times, and so on and so forth. But again, this is what we call a histogram. It's just a graph used to present quantitative data, and it's extremely similar to a bar graph. Okay. Just one note that the rectangles in histograms will touch, but the rectangles in bar graphs do not touch. That's just one small difference. Sometimes in StatCrunch, if we can't get the histogram feature to work, we'll use a bar graph. But the biggest thing is being able to read the histogram, because these right here, so these class widths are each representing a single unit 1. But these class widths are going to get bigger when our data becomes more dispersed. So the next thing I want to talk about, once you have a histogram, is you can identify the shape of the distribution. And it helps us describe how the distribution is going, how things look. And there are some classifications to be aware of. So symmetric, when you see symmetric, that's like a bell curve. So I'll show you an example of that. Then you have skewed left, you have skewed right, and those are 3 of the most common. Okay. So we're going to look at a figure right down here. I'll get down to it in just a minute. We're going to see a couple of symmetrics. And when you see symmetric, I mentioned bell curve, but another way to think of it is if you split it right down the middle, the right and the left sides are almost mirror images, or they are mirror images. There's a uniform distribution, and that distribution is going to be perfectly flat, equally spread across the variable. So if you look here, here's a uniform. It's also symmetric, because if you split it down the middle, it's going to look the exact same. But again, uniform, just nice and even, straight across the board. Okay, and notice this one right here, part B. If you were to kind of draw a single line, or curve, I should say, to try and represent that histogram, it looks like a bell. So we call it a bell-shaped curve. You're going to see that thing on and over and over again in this class. But just imagine if you were to fold down or cut down the middle, you'd have pretty much a mirror image. It's not exact, but it's pretty close. So we'd call that symmetric. Okay. Then you have right skewed. So what right skewed looks like is we have an early peak, and then it tails off to the right, gets lower and lower. So that's what we call right skewed. Left skewed, the tail is on the left-hand side, and then it peaks the farther you get to the right. So whether you're skewed right or skewed left depends on where this tail is, or where it tends to drift off or tail off to. So right skewed is going to just kind of tail off to the right. Left skewed, that tail will head out to the left. Okay, and these are going to be kind of the most used and most seen that we'll have in this class. Okay, so let's look at an example here. Okay, in this one we have a car salesman records the number of cars he sold each week for the past year. And we've got a frequency histogram for this. So again, we have the frequencies here. So those heights tell us frequency. So he had 0 cars sold, and that happened 4 weeks out of the year. So the height tells you the frequency, and then the kind of these bottom numbers tell you the actual number of times. So number is on the bottom, and then the height tells us the frequency of that number. So the first question, what is the most frequent number of cars sold in the week? So we peek out right here at 12, and that was 4. So 4 is the most, so 4 cars, I should say. Okay, for how many weeks were 2 cars sold? Okay, so when we look at for the number of weeks were 2 cars sold, so here's our 2, and that height there is 9, so that would be, there were 9 weeks. Okay, to determine the percentage of time cars were sold, so again, or excuse me, 2 cars were sold. That was 9 weeks out of 52 weeks in a year, which is approximately 0.173 or 17.3%. Okay, so that would be the relative frequency of 2. Again, because you have 52 weeks, so there were 9. So we have 9 weeks up here, so we take 9 divided by 52, and that gives us the 0.173 or 17.3%. Okay, and then lastly, we want to describe the shape of this distribution. If we look at the general shape, okay, we do have kind of this peak right here, and then it drops down, and then it's peaking up. So what we would say is, you know, if I were to try and make a general shape of this thing, it would look something like this. But we would peak early, and then we would start to tail off here. So the tail would be going to the right. We're stretching farther and farther to the right. So when you whichever way you stretch, that's where we are skewed. So this is skewed to the right. Okay, so that's just one look at analyzing a histogram. Okay, so this next one, we've got free throws. So in an experiment, a researcher asks basketball players to record the number of free throws she shoots until she misses, and the experiment is repeated 50 times. Okay, so we know that when we add up all the frequencies, it'll be 50. So we have the following table lists the distribution of the number of free throws until a miss is recorded. And the first thing we want to do is we want to construct a relative frequency distribution for the data. And just going to remind you how we find this. I'm not going to do all of them, but just how we do this. So I'm just going to create a little table here. So one that occurred 16 out of the 50 attempts, so that's going to be 0.32. And then 2 occurred 11 out of 50 times, so that's a 0.22. Okay, and then 3, the relative frequency of the 3 occurred 9 times out of 50, so that's a 0.18, and so on and so forth. And so that's how we found the relative frequency by hand, and you would continue that on, but StatCrunch does this quite nicely for us. Okay, so I'm going to come over here. Here is all of my data that I've already input. Okay, and I'm just going to go over to Stat, Tables. Let's see. Oh, actually, kind of work around when I don't have the hard data. I've just got the frequency distribution. One of the workarounds is to do a bar plot with summary, because the categories are in the number of free throws and the counts are the frequency. So I want to do a relative frequency on this bar graph and put the values above the bar. And I'm going to spread this out. You can see here is my relative frequency. So I'd have a 0.32, a 0.22, a 0.18, then a 0.14, 0.04, 0.06, and then 0, 0.02, 0, 0.02. So you can see we started out as 0.32, 0.22, 0.18. So that's a look at how we did that. I'm running out of time, but we'll continue to part 2.